Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon to everybody. Welcome back to our class MEC522 Control Engineering. Okay, my name is SOLEHUDDIN. You can call me Dr. Soleh. This is my phone number and this is my room number. As I mentioned last week, for this class we are going to explain the fundamental and the basic concept of modern control engineering. And then you should be able to derive a mathematical model of dynamic system, okay, and then apply it to a wide range of problem in control system. Okay, and then as for the practical aspect, which is for the lab, we're going to use computational tool which is Tinkercad, okay, to do the analysis of the control system. So for this class, we are going to cover the following, which is the introduction to mathematical modeling and control engineering, system of industrial control device and system. And then after that, we are going to look at the basic concept and principle of feedback control. Then to look at what will be the system stability and what will be the criteria. Then we're going to look at performance specification, frequency response analysis, okay. And then we're going to look at different control application. So what we have done last week is bit on the introduction and the review of Laplace transform, what element in control systems about, okay, open loop and closed loop system, different type of controller, and then a bit on the introduction to simulation tools for control system design. Okay, so for this week, which is for today's lecture, I'm going to cover the aspect of mathematical modeling of engineering system. Okay, we are going to look at the mathematical modeling for mechanical system, okay, and then mathematical modeling for electrical system, and then we're going to look at electromechanical and electronic system. So during your time, I think the projection of technology that will be the national focus. First thing is more on aerospace. That one will be the national focus, and then they talk about smart farming. Okay, smart farming. And then last but not least, they talk about electronic, electrical and electronic system, which is related to the topic that we are covering now. Okay, so that one would be the focus of our country and our region. So the job will be circulated among that area. Okay, the dana, the amount of grant funding. Okay, so this is what we're going to do today. I'm going to recap a bit what we have done last week. Okay, this is the handout that I have given to you. But today with a bit on update with the example of it. Okay, we look at this example. Okay, the diagram of the robotic arm. Okay, if you look at this example, this robot joint, okay, you can see as a comparison. Okay, robot arm with a human arm. Okay, this is a degree of freedom of human arm. Okay, this one. And then this one is the degree of freedom of the arms of the robot. Okay, you can see here. Try to the first one. We have the movement of the shoulder. Okay, to swing the arm while walking. While walking, your shoulder swing the arms while walking. Go this way, this way. Okay. Okay, and then step number 2 you can see is the movement of the shoulder when spreading out the arm. Okay, movement of the shoulder you can try. Okay, movement of the shoulder when spreading the arm. Okay, spread the arm, and then you try on your own. Another one is the steps. You can see 3, 4, 5, and 6. You can see. Um, can see the movement, okay, movement of over here. You can see movement of the wrist, okay, our wrist when striking the hammer. When try to strike the hammer, which is number 7. Number 7, you want to hold something and then you want to strike something, okay, by using a hammer. And then this is the movement of the wrist while exerting force while arm wrestling. We do arm wrestling. Okay, a different type of movement, exertion. Okay, can rotate this way. Okay, bend in and out. Okay, and then you can also rotate. Okay, this is what we call the degree of freedom of human arm. Okay, okay, this is the created by the creator. And this one, we are the human being who design it. Try to mimic with the one with us, okay, of human arm. Degree of freedom here, you can see we look at from bottom to up, bottom up. Okay, this one, the first layer we call S axis, which is a swing. So what happened here? A swing axis is the axis to rotate the body, okay, the whole body, rotate the body. And then we proceed to the next layer is what we call L axis, okay. L axis is we have here lower arm, okay, lower arm, the axis to move the body forward and backward. So we have the main body, then it can move the body forward or backward, okay. So this is what we call a lower L axis, and then another one we have what we call U axis, which is upper arm. L is lower arm, then the one the next layer is what we call upper arm. So this upper arm, the role of it is the axis to move the body, to move the arm up and down, okay, because it will move the arm up and down, okay, up and down, okay. And then another one, we will have what we call R axis. We have S, L, U, and then we have R axis, which is what we call wrist, our wrist rotation, okay, which is to rotate the arm. Okay, that's a function of R axis. And then we have another one, what we call is B axis. B axis. This is wrist bending. Okay, bending of the wrist, B, this one, and then last but not least is T axis, which is wrist bending. Okay, so the human arm basically is complicated when we try to convert our work into the arm of the robot. Basically it's not a straightforward thing. It's complicated. Okay, so we have here S axis, L axis, U axis, R axis, we have here B axis, then we have T axis. Okay, all right, and this is the block diagram of a typical robot joint. Okay, we have input here, control, put current back, power interface block, then DC motor, and then we have robot dynamic, and then this is the feedback. Go back to the transducer of the position. Okay, this one, what we have done last time, the process of solution to get Laplace transform. Step 1, by the given ODE, ordinary differential equation, and then step 2, subsidiary equation, and then the solution in step 2 we transform. Okay, so to get back uh, the result in the solution. Okay, so we have went through the example. I hope you went through there on your own. Okay, example 1, how to get the solution for example 1, and then we went through example 2 for dampened vibration. Okay, and then get the solution and plot the graph. And then this is a additional sample for suspension system for sinusoidal input. Okay, sinusoidal input. Okay, and then we have to find the displacement using Laplace transform. Okay, I hope you can go through all of these. Okay, it's a straightforward. We have shown here step by step and how to use table 1.1 to obtain the value. Okay, all right. This is the table that I'm talking about. I'm referring to. It is some function ft, and then the Laplace, their Laplace transform. Okay, 1 over s, t 1 over s square, t square is 2 vectorial over s cube, and then the one related to cosine. Okay, sine, hyperbolic cosine, and the one which is related to exponent. Okay, exponent. So I hope you can try to do this tutorial number 1, which is the extended exercise. Okay, find the Laplace transform. Okay, then find the inverse Laplace transform. Okay, all right. Laplace transform for all of this. You can try on your own. Okay, this is our tutorial. Okay, now it's 2:30. I proceed with the order of our class. My lecture, I will cover mathematical modeling, and then after that system model representation. So we are going to do chapter 3 first, and then come back to chapter 2. Okay, so you can download this note. Okay, I have upload in your Google Classroom. Okay, I will enlarge this. Can you see this note?
Yes.
All right, good. Let me look at this one. Okay, we proceed to to this node, which is mathematical modeling. Okay, mathematical modeling. So we are going to do mathematical modeling for mechanical system, electrical system, and then electromechanical and electronic system. Okay. For fluid and thermal system, I leave it to you to study on your own. Okay. But for our class, we are going to cover only these three. Okay. Okay, we're going to go through this note. Uh, First thing, when we say mathematical model, but what does it mean? Anybody want to respond? We would like to have a mathematical model. So engineer, we should be able to look at the problem, the existing problem that our normal people see, and then should be able to simplify it and show it in terms of mathematical model. So what does it mean by mathematical model? Anybody want to try? So now you are in semester, which semester now are you now? 6, right? 6 or 7?
6.
Semester 6. Meaning you are almost towards the end, yeah, to become an engineer. So basically, what mathematical model is all about? Because some people they are afraid we talk about mathematics. Oh, you cannot. They say, oh, that one it's not my strength. Right? So basically, what mathematical model is about? Be as an engineer.
Using mathematical concept.
Okay, because engineer we apply mathematics and physics, right? To solve engineering problem. So what we are doing now is we're going to analyze and uh, analyze the system. Okay, that's why in control system you must understand how to model dynamic system. Okay, and analyze the dynamic characteristic. Okay, because the way we look at the mathematics, the equation is not the same with mathematician looks at the equation. It's not the same because it will have a physical meaning of it. Okay, that's why we cannot see the engineering problem similar like mathematician, and that's why uh, you need to understand and explain the physical meaning of it. Okay. Um, so if you look at here, what been mentioned here, mathematical model of a dynamic system. Okay, so it's been defined here. Mathematical model of since we are study control system, we are talking about a dynamic system. So mathematical model of dynamic system is what? Is a set of equation, okay, that represent the dynamic of the system accurately, okay, or at least very closely, and so we can predict what will be uh, the answer or the outcome of it. Okay, so we can approach or obtain the answer not only by having one technique, we can solve it in different way. Okay? There are many ways to the system to be represented. Okay? Therefore, we can have many mathematical models depending on one's perspective. How do you tackle them? Okay? So what we have here, the dynamic of many systems, as I mentioned just now, they are mechanical, they are electrical, thermal, economic, biological, and so on, and so on. Okay, so we can get we can do the setup of the model, depend on the application of it. Okay, even in biomedical also we can construct the mathematical model of it. Okay, so it may be described in terms of what we call differential equation. Okay, that's why you learn mathematics before differential equation, ordinary differential equation (ODE). Okay, so they are governing using a physical law governing particular system. Okay, for example, we have in mechanical we have Newton's law. Okay, we have if in electrical system we have Kirchhoff law, okay, for electrical system. So in mechanical we have Newton, in electrical system we have Kirchhoff law. Okay. So as an engineer, you should be able to know all of this. Mechanical and electrical, they are related and they are very important to combine these two, especially in the area of industrial IR 4.0. Lot of mechanical and electrical system. They work together. Okay, even the top car company, automotive company, these two must work together. Even MME also they work together. A mechanical consultant to design aircon, electrical system, um, fire, and then the elevator. Those are very important for building services. Okay? So they work together, this consultant. Okay. So as an engineer, okay, trained to be engineer, you must always keep in mind that the deriving reasonable mathematical model is the most important part of the entire analysis of control system. Okay. So jangan takut when kita kata mathematical model ni nak kena very complex mathematical is not. Because right now we have many tools. We have Mathematica, we have MATLAB, we have different mathematical tool like to convert, to compute the value, to get the inverse matrix, to do the calculation. Okay. So the main thing you need to know how to use it and where to find it, okay, and apply. Okay. So this is what is meant by first paragraph. And now we straight away go to the question that I have asked you just now, okay, which is a mathematical model. Okay, it's a description of the system in terms of equation. So when we have certain system, okay, so what will be how to transform that system into equation. Okay, so that's why you are different from technician or from other people, because we should be able to describe the system in terms of equation. Okay, how the bird fly, and then what would be the how the system of the tree system. Okay, layer by layer you can explain in terms of equation. Okay, thermal system also, the the different temperature gradient you can also describe in terms of the system, flow of the pipe, and then flow of the blood in our artery also you can explain and convert in terms of mathematical system. Right? And that's why the thinking part should be there and relate with the concept, mathematical model concept that you have learned. So mathematical modeling is a procedure to construct a model, okay, of a dynamic system based on physical law. So we have here, we have physical law here is Newton. One of it is Newton law, okay, that the system element and their interconnection are known to obey. Okay, okay. That's why mathematical modeling is very important. In the dynamic, you've been exposed how to construct the equation, free body diagram, and then write down equation of motion from there. And that is the starting. It is starting. Same thing with in vibration also you have learned how to construct mathematical model. Okay, when you learn at that literature like subject also you have learned about different literature system. You should be able to relate. Okay, next one is what we call after this one mathematical model. I proceed to explain about dynamic system. Okay, dynamic system. So what is a dynamic system? Okay, systems dynamic. Okay, system dynamic. Okay, dynamic systems. Okay, what is meant by dynamic system? Okay, we have done this one model. Okay, anybody want to try? What does it mean by dynamic system? We have 20 students. 6 students they are not coming today. Maybe they can refer to the recording. Anybody want to try? Saiful Fazli, what is meant by dynamic system? It's not here. Okay, Hafizuddin, what? Muhammad Hafizuddin.
Yes, sir.
Okay, what does it mean by dynamic system?
Saya rasa dari situ macam ada beam, ada force, ada creation force macam tu kan.
The beam.
That has force and the reaction force. And this to be like friction.
Okay, thank you. Any other answer? Apa lagi nak cuba? Tengku Fakhruddin.
Yes, betul. Uh, I think dynamic system is um, is about a system that receive and receives multiple signals and conditions.
Multiple signals. Okay. Signal. Okay. Enemy system. Alright. Any other answer? Mana lagi ni? Tengok ramai ni. Are you here or not? Oh, Zuhairi. Muhammad Zuhairi. Muhammad Zuhairi, Zul Fazli. So the term that I put emphasis here is the terminology that you're going to, come across again and again. Yeah. That's why you need to really know what this is about. Okay, so if you look at here, we define as we have variables, okay, which are time dependent. Okay, as been mentioned by one of your friends just now, this system can respond to input signal. Okay, and it can also respond to disturbance signal. Okay. Remember the diagram that I mentioned just last time? We have the input, we have input signal, we have disturbance. Okay. Dynamic system also can respond to initial condition. For example, we have pre-stress, pre-compress of this, for example. It depends on the initial condition. Okay. So we have to put all of that into consideration when we do the analysis. Okay. So in many cases, the signal that produced by the system we can measure. Okay, we can measure. That's why we use what we call we can construct a model. We have this block diagram. Okay, so the procedure to construct the model based on the measured data. That's why we call system ID. Okay, system ID. So system ID we're going to cover in the next chapter. So we are going to have what we call a systematic procedure, like a cookbook step by step, to construct a model based on a measured data. Okay. So the process of using mathematical modeling to find certain features of the system, cause and effect relationship, we refer this process as solving the model, or what we call the simulation. That's why we have so many simulation software. When you do your final year project later on, okay, then when you do, especially right now during pandemic, we encourage students, most of the students do the simulation work. This is simulation works means it doesn't mean like we have input here, we have output here. So what happened inside? So when you are using a software, this is like a black box. That's why students should be able to explain what happened. Should be able to explain. They should be able to explain what's happening in this world. That's why the knowledge of mathematical modeling is very important. Okay? We require the understanding, okay, of certain problems, okay, and mechanical, electrical, okay, if we are doing both, okay, that's what we call simulation. Okay, these are the steps in modeling and simulation of dynamic system. Okay, um, starting with actual physical system, our interpretation, based on our knowledge, what we have learned, and then an experience, and then we have a mathematical representation, then we calculate the response, and then we do the performance analysis, and then we do modification. So when you do the work, They cannot be first time, you see, do the first time, then cepat-cepat we obtain the response and then find the performance and then we are satisfied. No, cannot. You need to have a number of iteration. Okay? Number of iteration. Okay, number of iteration, number of modification, should have different design changes and then do it again and again. But when you do simulation compared to experimental work, when you do experiment, it involves a lot of money, cost to prototype and then you do the testing. But when you do simulation, you can do many and try to get the optimum one. What will be the best one? And then after everybody is satisfied, team of engineers satisfied, your superior satisfied, and then you can start to fabricate and do testing or proceed further. That's why modeling and simulation is very important. Okay. So these are the fazilat or kelebihan or advantages of modeling and simulation. I think I have mentioned last time, but I think I will say it again. Many big company right now, as I mentioned, they move from the traditional way of doing testing. They do this one, move on modeling and simulation, because they have a lot of advantages. We allow predict the behavior of the system before it built. So can predict the behavior of the system. Okay, so that's why we call this virtual prototype. Okay, virtual prototype. And then another advantage of it is you can analyze. First, you prototype, and then you can analyze the performance of it. Okay, you can analyze the performance of the existing system. Okay, because our intention is what we want to do is we want to improve the dynamic behavior. Okay, so by analyzing the performance of it, we can see is it okay or not okay. Okay, in comparison of the other system. So our intention, of course, we want to improve the dynamic behavior. And another one is we want to find what will happen. Okay, this is the worst case scenario. You can predict by putting the unusual input, for example, what will happen. Okay, the worst case scenario, what will happen to the system. Okay, you can find what will happen to the system. I mentioned here with the unusual input or condition. Okay, so that the actual system will have we can reduce the risk of it. Okay, the condition, in what condition, even though we have an unusual condition or unusual input, does it will reach the actual system. Okay, and then last but not least is you can do forecasting. Forecasting mean here not like you see the Momo or fortune teller to predict the future. No, for simulation you can do forecasting based on the data that we have, which are closely related. You can project the trend. For example, here trend, and then what will happen? For example, in 5 years time, what will happen to the system? For example, whether based on the simulation and modeling that we have, so we can predict the future. Okay, okay. That's why this what we call modeling and simulation is very important. Okay. Okay. 3.2 is a model for dynamic system. As I mentioned just now, mathematical model, we derive it from law of physics. Okay, law of physics, and engineering properties of each system component. So to solve this dynamic system, the form is going to be in the following form. First is to configure the form, how to configure, configure it. Okay, and then number 2 is space representation. Okay, and then comes number 3 is input output equation. Okay, that's why here we are going to use a differential equation, and then last but not least is transfer function. So when you have transfer function, you can start to move or to work, to make it work. Okay, these are the forms, preferred forms for dynamic system. We're going to look at it briefly. Okay, briefly. These 4 steps. Okay, these 4 forms. Okay, 4 forms. Okay, so we'll start with configuration form. Okay, so for configuration form, how to configure it? Okay, so this model, we can configure it. We can write, it can be written as the following. We can have in this form, you can see a Q here, Q double dot, okay, equal to AF, and so this function, as a function of Q, we have Q dot, and then T. Okay, and then you have the initial condition has been given, QO, and then Q dot. Okay, so this is equation 3.1. I think this form you're familiar. We have done in dynamic, in vibration, in dynamic, in vibration lab also. We have done this. I think you will be very much familiar. Convenient form. This is a standard form, standard second order matrix. You can see how we write it down and relate with this configuration model. You can see M. Okay, this is M. M refer to mass, right? And then Q double dot plus C here is the damper. Okay, C is a damper, M is a mass. Okay, and K is a spring stiffness, and Q here basically is a vector. Okay, I use Q as a vector of the generalized coordinates, while F is also a vector, but it is a generalized external forces. Okay, so Q, we have a vector of a generalized coordinate, and F is a vector of a generalized external force. Daya-daya yang luaran tu. Okay, this is external force. Okay, all right. This is what we call, we have to write in the configuration form. Okay, configuration form. we have the function of q dot with respect to time. Okay. Okay, we take a 5-minute break. Okay, 3:05, we're going to continue. Proceed after this with state space representation, transfer function. Okay. Okay.